Okay, for lesson 4, let's continue where we left off last time. Last time we were talking about the family tree of numbers. Let's write down some just to remind ourselves. So lesson 4, we'll start by writing down some rational numbers, some integers, and whole numbers. Of course, don't forget there's natural numbers, but natural numbers are whole numbers, not including zero. Natural numbers are your counting numbers. So rational numbers, let's just write down some. So negative a half, 3, 0.68, negative 12, and then let's go big, 1051. These are all rational numbers because they can be written as a fraction. All right, let's get some integers. So -8, -7, -6, -5, -4. I'll skip some. 0, 2, 9, 1051. These are all integers. And lastly, let's put down some whole numbers. 0, 1, 2, 3, and etc. So I'll just go dot, dot, dot. All right, let's look back at our 6th grade curriculum map and see what we're going to work on for today. So for Unit 1, it's all about the number systems, and that's what we're talking about. In particular, you got to make sure you can add, subtract, multiply, and divide, not only multi-digit decimal numbers, but whole numbers, fractions. That's what elementary school was all about. So you and I, let's focus on this thing that's called a GCF and an LCM. So GCF stands for the greatest common factor. LCM stands for the least common multiple. So let's go back. So our topics for today, GCF. And of course, we'll write out what it really is. The greatest common factor. And then, of course, we're going to have the LCM, which is the least common multiple. So let's break down their names and let's see what they're trying to tell us. So what is another word for the greatest? Well, hopefully you said the biggest. Common. Common is what they share, what they have, both of them have. And then factor. Well, how do we get factors? By dividing. So the greatest common factor is the biggest number that the two numbers share, meaning they can both be divided by that number. So the biggest number that they can both be divided by. So let's write that down as a better definition. The biggest number that can divide both. And when I say both, what am I referring to? Let me go back to the map real quick. It says, compute the greatest common factor of two numbers less than or equal to 100. So when I say both, what am I talking about? These two numbers. These two numbers have some number that can divide both of them, but it has to be the biggest number that can divide both of them. All right, back to our lesson. I'm gonna go ahead and erase this and I'll put it in a moment. So if you wrote it, go ahead and erase it. All right, let's try to get some examples and we'll start with small numbers, okay? So example one. And our two numbers will be, let's start small, 12 and 18. So my two numbers are 12 and 18. So first of all, I need to write down all the factors of 12. So when we say factors, we mean numbers that will divide into 12. So let's write down all the numbers that will divide into 12. And to be organized, I'm going to write 12 and then I put these colons, the dots. All right, so I know 1 can divide into 12 because I can do 12 divided by 1. I can do 12 divided by 2. I can do 12 divided by 3. I can do 12 divided by 4. I can do 12 divided by 6. I can do 12 divided by 12. Okay, so those are all the factors. So now let's do 18. All right, so I know I can do 18 divided by 1, 18 divided by 3. Oh, I skipped one. 18 divided by 2, 18 divided by 3. You cannot divide 18 by 4 or 5, but you can do 6. It's not 7, not 8, but you can do 9. And then not 10, not 11, not 12, not 13, not 14, not 15, not 16, not 17, but you can do 18. So these are the factors. So now when I need to find the GCF or the greatest common factor, I look at both of my lists and I'm looking for the number that they have in common that is the biggest. So I give you a moment to look at it. You're thinking about it. Do you see which one it is? Well, hopefully you see it's this one, 6. So 6 is the greatest common factor between 12 and 18. Here, let's do one more example just to make sure you are following along. Let's go big this time, okay? So let's go 55 and 35. Okay. So now I hope you understand there's tricks to this, but for now, we're just going to do it the long way. And the long way says write out all the factors of each number. Now, 1 will always be a factor of every number. So I'll start with 1. Can I divide 55 by 2? No, because 55 is odd. You can only divide even numbers by 2, so that's out. What about 3? No. What about 4? What about 5? I can do 5. Now, off to the side, I'm about to write something. 1 times something will give me 55. And 5 times something will give me 55. 1 times 55 will give me 55. And 5 times 11 will give me 55. So I'm going to save myself some time and not go, can I divide 55 by 6? Can I divide 55 by 7? Instead, I'm going to say, oh, it's 11 because 5 times 11 is 55. And then the last number is 55. These are the factors of 55. Now, you may be taught this thing called a factor tree, or you may have already been taught it, which is great. If you haven't, you write the number and then you put these legs underneath it and you say, okay, what two numbers can I multiply together to get 55? Well, 5 times 11. And then you say, well, what numbers can I multiply together to get 5? Well, 1 times 5. And what numbers can I multiply together to get 11? 1 times 11. So now you can see all the factors of 55 are staring at you, right? 1 is here, 5 is here, 11 is here, and 55. I don't have to write the repeated numbers. Yes, I see another 5 and another 1 and another 11, but I'm not going to write those. So if I'm dealing with small numbers, I can just write out the factors, no problem. But if my numbers get bigger, I might want to use a factor tree. Okay? All right, so now 35. Let's do a factor tree for 35. What two numbers can you multiply together to get 35? Hopefully you said 7 times 5. Okay. What numbers can you multiply together to get 7? Hopefully you said 7 times 1. What numbers can you multiply together to get 5? Well, hopefully you said 5 times 1. So now look, 1, 5, 7, 35. I don't write down the repeated ones. These are the factors of 35. And if you're really good at this, you won't even need to have to do a factor tree because you know your times table and tables in your head. And if you know that, well, you're doing great. If not, you can do a factor tree and still be great. Okay? So now, let us look at the factors of 55 and 35. And once again, let's find that GCF. So I give you a moment, you try to find it. All right, your moment is up, and hopefully you said 5. So GCF is the greatest common factor. That means the biggest number that can divide both of the numbers. So in example 2, the biggest number that would divide 55 and 35 was 5. In example 1, the biggest number was 6. All right, so that's GCF. Let's go look at LCM. Remember, if I'm moving too fast, that's what the pause button is for. LCM. And what does that stand for? Least common multiple. Now, if you ask me which one is easier to find, the GCF or the LCM, I will say the GCF is the easiest one to find. The LCM involves a little work. Okay, so let's break down what they have here, have written here. Least. What is another word for least? Hopefully you said the smallest. Common is, what they share. And then multiple? Well, that's multiply. Multiple is multiply. So maybe off to the side, I need to write some examples of some multiples. So for example, let me write some multiples. So what about 2, 4, 6, 8, 10, 12, 14? Now it looks like I'm just writing even numbers, but I'm really writing the multiples of 2. Multiples of 2. Why? Because I can do 2 times 1 to get 2, and I can do 2 times 2 to get 4, and I can do 2 times 3 to get 6, and 2 times 4 to get 8, and 2 times 5 to get 10, and 2 times 6 to get 12, and 2 times 7 to get 14, and etc. It goes on forever. So we'll just put dot, dot, dot. So you see, multiples actually involve some work. Okay, so let's go back to our curriculum map. Let's read what they have for us. Compute the least common multiple of two numbers, both less than or equal to 12. Well, you know what? I didn't even read the 12. That makes this a lot easier. I thought it had to be 100. This is a lot easier when it's 12. All right, let's go back. So now let's pick an example. This is example 3. Oops. All right, so we want to find the least common multiple between 6 and 4. Now, I want you to know there's many ways you can do this. So I'm just going to show you one way, or maybe another way, and we'll see how you like it. All right, so in order to do that, I need the least common multiple between 6 and 4. Now, I wonder if you already know it. Do you? If you said 24, you're wrong. 24 is a multiple of 6 and 4, but it's not the smallest. Are you thinking about it? Well, let's see if we can do it together, okay? So I'm going to start by writing 6, and because these numbers are going to be less than 12, I'm going to show you this way, okay? I'm going to show you this method and see if you like it. Write out the multiples of 6. So that means 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, and etc. So that's 6, 12, 18, 24, 30, and then I'll put dot, dot, dot because this list goes on. Let's write out the multiples of 4. That's 4 times 1, 4 times 2, 4 times 3, 4 times 4. So that's 4, 8, 12, 16, 20, 24, 28, and it goes on. So then remember, you're looking for the least common multiple. So now I'm going to look inside the list and I'm going to find the smallest multiple they share. I see 24, but that's not the smallest. The smallest is 12. So the least common multiple between 6 and 4 is 12. Now, let me see if I can show you another way to do it. What if I did it this way? So this is example 3 continued, just showing you another way to do this. Let's see if you like method 1, which has you write out your multiples. I realize I'm writing a lot of words today. I hope you understand you don't have to write everything I do. So like this over here, I hope you didn't write it because that was just me talking and showing you something. If you did, okay, but you might run out of room on your paper. All right, so let's continue example 3 and let's try another method. 6 and 4, and I'm looking for the least common multiple. So this time, I'm going to actually start by writing the factors of 6 and the factors of 4. The factors of 6 and the factors of 4. And remember, factors are numbers that will divide into it evenly. So 1, 2, 3, and 6. Those are the factors of 6. And then I'll write out 1, 2, and 4. Those are the factors of 4. Now, this method may have been better if I wrote it like a factor tree. So don't erase anything. I'm just going to write it like a factor tree. I do like method one better if you want my opinion. Okay, so now you might be wondering why I'm not writing 1 times 2 underneath the 2 and 1 times 3 underneath the 3. That's because once I have prime numbers, I can stop. 2 is prime, 3 is prime, 2 is prime, 2 is prime. So now here's the trick. You want to multiply the factors together, but you don't want to multiply by the repeated factor. So what do I mean? I mean, right here, I have two twos to make 4. I only want to take one of them. But for 6, I have 2 times 3. These are different, so I'll take both of them. So the least common multiple would be 2 times 2 times 3. And that is also 12. And this is method 2. Method 2 may be a little complicated for you right now. So for now, I will at least use method 1. Well, if you want to try method 2, maybe watch some YouTube videos to really see how you can do it, you can do so. All right, so one more example, and then let's recap so we can end the video. So this is example 5. We're going to find the least common multiple between or of, and because it's least common multiple, we gotta make sure we keep our number less than 12 because that's what your curriculum map says. So I'll just do 12 and I'm thinking 8. Okay, so let's find the least common multiple of 12 and 8. And then let's also find the greatest common factor of 12 and 8. So part A is the least common multiple. All right, so I'm going to do it method 1, the way we did it the first time. I'm not going to do the factor tree. That's a little too complicated for you right now. So we'll start by writing out all the multiples of 12 and all the multiples of 8. Now, I'm going to start by writing the big number first, and then I'll do the 8 second. And there's a reason for it. And let me just show you as I go. So 12 is the multiple of 12. What's 12 times 2 is 24. Or 12 plus 12, just keep adding a 12. 36, keep adding a 12. 48, keep adding 12. 60. And then it keeps going forever, right? All right, let's write out the multiples of 8. Well, 8, 16, 24, 32, 40. Do you notice that I could have already stopped? Why I could have already stopped? Because once I see they share 24, that is the least common multiple. That's the smallest number that they have in common. So the least common multiple of 12 and 8 is 24. Not bad. All right, let's do the greatest common factor of 12 and 8. Okay, so I'm going to do the same thing that I did above in our example 1 and example 2. I need to write out the factors. So the factors of 12 are 1, 2, 3, 4, 6, and then 12. And the factors of 8 are 1, 2, 4, and 8. All right, so what is the biggest factor that they have in common? It is 4. So as a recap, remember, we're dealing with number systems. That includes rational number, integer, whole number, natural number. You got to make sure you can add, subtract, multiply, and divide whole numbers and decimals and fractions. That's what you were taught in elementary school. In sixth grade, and probably seventh grade, well, sixth grade, not in unit one, but eventually, maybe unit two, we can look in a moment. You're going to be adding and subtracting and multiplying and dividing integers, which means negative numbers. But for today's video, we just worked on the GCF and the LCM. GCF, greatest common factor. LCM, least common multiple. If you want my opinion, I suggest you watch this video over and over and over to practice finding the GCF and the LCM. And then if you like going on YouTube, I would go on YouTube and I would type in sixth grade GCF practice. Or you can type in sixth grade LCM practice. And then you can practice and test yourself and see if you really understand what you're doing. All right, so this is the end of this video. Thanks for watching. I'll see you in lesson 5.